is AP Calculus AB. We're in Notes 2.5. This is part 2 of 5. We are going to check out this graph that you see here and answer questions 5 through 9. Pictured is the function g of x. Use the graph and the equation to answer questions 5 through 9. Question 5. Based on the graph, at what value or values does the graph of g of x have horizontal tangent? Give a reason. Show an algebraic analysis that supports your answer. So we got to find at what values does it have a horizontal tangent. We have to give a reason for it. And then we're going to have to show an algebraic analysis. I think that you can see that there appears to be a relative maximum here when x is 1. As a result of that being a relative maximum, we know that this would have a horizontal tangent at x equals 1. Let's write that down. G of x appears to have a relative maximum at x equals 1. Conclusion, therefore, g of x has a horizontal tangent at x equals 1. So we just did two things. We gave a reason. It's right here. See if I can space this out a little bit better. Gave a reason, and then we wrote our conclusion, which the original question was, at what values does the graph have the horizontal tangents? So that's done. And then we're supposed to show an algebraic analysis. Well, in order to show an algebraic analysis, we got to take the original function, we got to take the derivative and set it equal to 0. The reason we are going to take the derivative is going to give us the slope of all the tangent lines. The reason we set it equal to 0 is because to have a horizontal tangent line, you're going to have a horizontal slope, and a horizontal slope has a slope of 0. Before I take this derivative, I want to write this in quote-unquote polynomial form. So I'm going to change the square root of x to x to the 1/2. That's in rational form. So the derivative of g with respect to x, this is Leibniz notation. Take the exponent of 1/2 and multiply it by 2. 2 times 1/2 is 1. Subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. This next term, derivative of negative x, is minus 1. Derivative of 2 is 0. So I don't need to write the 0. Once I found the derivative, I need to set it equal to 0. And I'm going to rewrite this back into radical form. You don't have to. I'm choosing to because it's easier for me. I'm just going to make a note here that g prime of x is equal to 0 for horizontal tangents. You would not need that on a test or a quiz or homework. I'm just trying to make sure that we understand why we're setting it equal to 0. If I then add 1 to both sides, and then multiply both sides by the square root of x, and then if I were to square both sides, I would get x is 1. That verifies algebraically that our assumption is that g of x appeared to have a relative maximum at x equals 1 was confirmed. Just going to write this formally. G prime of x equals 0 when x equals 1. Therefore, g of x has a horizontal tangent at x equals 1. This part right here that I'm putting in this box is overkill for the question that's being asked, like on a test or a quiz. But it's not overkill for your understanding of what just happened. This is basically a better version of what I wrote up right up there. Number 6. On what intervals is g prime of x less than 0? Give a reason for your answer. Once again, I'm going to copy this graph down here so I can see it when I'm answering this. So the question you got to ask yourself, what would it take for the graph of g to make g prime less than 0? That would be for g to be decreasing. If it's true that this is a maximum here, a relative maximum, then to the right of it, it's going to be decreasing. So we could say that, so there's two things to do. On what interval, and give a reason. I'm giving the reason first. You don't have to, I'm going to. G of x is decreasing. It's right after the relative maximum, so that's from 1. And if you look, it's decreasing forever to the right. There's an arrow. So it's a 1 to infinity. 1 is not inclusive because 1 is at the maximum. The conclusion we can draw from this is that g prime of x is less than 0 on that same interval. So this is the interval. The answer is the first part of the question. This is the reason. The answer is the second part. If you'd rather write this first, you can, then just write because, and then give this as the reason. Number 7, on what interval is g prime of x bigger than 0? Well, g of x is increasing from 0 to 1, both non-inclusive. Looks like the graph is starting right here. It's increasing until it gets to the relative maximum. So it's increasing on that interval. Both are non-inclusive. And then our conclusion from this is that g prime of x is greater than 0 on that same interval. Number 8, for what values of x is the slope of the tangent line equal to 2? Show your work. If we take the work that we did here, which is the derivative, so let me, before I do that, what this is asking you to do is asking you to find x when g prime of x is equal to 2. So take the derivative and set it equal to 2 is what it's asking you to do. So I'm going to take this derivative here, but instead of writing x to the negative 1/2, I'm going to write this version of it because it's just easier for me to work with. So g prime of x is equal to 1 over the square root of x minus 1. For what values of x is the slope equal to 2? This represents slope, g prime. So I'm going to replace that with 2. Before I continue, at the risk of overstating this, for this question here, we're supposed to find a horizontal tangent. We took the derivative, set it equal to 0, because horizontal lines have a slope of 0. Here, it just tells us that we want the slope to be 2. So we set the slope in for 2, just like we did 0 for this last one. If we add 1 to both sides, we're going to get 3 equals 1 over the square root of x. If we multiply both sides by the square root of x, if we divide both sides by 3, if we square both sides, we're going to get 1/9. For what values of x is the slope of the tangent line equal to 2? It's x equals 9. Show your work. Our work is clearly shown. Doesn't ask us to give a reason or anything like that, so that we are finished with this. We have accomplished what we were supposed to accomplish. Number 9, find an equation of the tangent line drawn to the graph of g of x when x equals 4. Then draw the tangent line on the grid above. So let me bring that picture back that I just had here. So in order to do this, we need a point of tangency and a slope of tangency. Point of tangency, pretty easy if you have a graph. When x is 4, it looks like the y value here is 2. So this is our point of tangency, which is the ordered pair 4, 2. Slope of tangency, not so simple. We take the slope of all the tangent lines, which is 1 over the square root of x minus 1. And we got to put a 4 into this to figure out what the slope is when x is 4. It's going to be a half minus 1, which is negative 1/2. Sorry, technical difficulties. User error, if you will. Point of tangency, ordered pair 4, 2. Slope of tangency is negative 1/2. Tangent line is y minus y sub 1 equals the slope times the difference of x and x sub 1. Just confirm slope, yes. Y sub 1, yes. X sub 1, yes. Find the equation. We did it. Draw the tangent line. We haven't done that. So we have the point of tangency. It's at 4, 2. And we just use the slope to find other points. So we can go down 1 and to the right 2. We can go up 1 and to the left 2. Please use a straight edge to draw this. Exaggerate the point of tangency. And we have concluded this second example. I'm going to stop this video here, and then I will make a separate video for the next 3 prompts that we have.